Colton, say hi to the camera.
All right, so welcome back. We'll talk about our projects at a later date, but we have a rare opportunity here because we have some visiting alumni. They graduated here in the program. So we have Lance, who graduated in 2022. He's currently at Cal Poly Pomona in the civil engineering program, so he's going to be sharing about his experiences and giving you some insight about what he's doing and sharing his thoughts about the program there and the things that he's involved with. And then we also have Ting, who graduated a year later in 23, and he's currently at Pratt in New York doing architecture. So we have civil engineering and architecture today. And these guys were literally in, well, they were at these seats, but maybe in the room next door. But they're here to share with you today and give you some insight into what they're doing as part of our whole kind of career readiness and getting you to understand different options that may be available based off of things that you see and the interest level that you may have. So let's give these guys a big bulldog welcome back. And Lance, the floor is yours.
All right, so my name's Ayala. He already said it. And then I'm going to be talking a little bit about structural engineering, which is kind of like a more focused version of civil engineering. Now, actually, I'm going to ask a question early. So, which class is this? Like CEA, IED?
CEA.
Oh my gosh, two. Okay. So you guys, so who in here is like interested in civil engineering at least at some point? Like they could see themselves doing this as a career or just want to learn more? Okay, so I imagine you haven't gotten too deep into like definitions and everything, but I'll get to that in a little bit. So first off, with a little bit of background, my name is He said it once. I go to Cal Poly Pomona. I'm a civil engineering major, and then I'm taking all my structural classes there because they offer a lot. And I'm currently a fourth year. I'll be graduating this spring, and some of my involvement within the school, there's two teams that I've been involved with. One is called PCI, one is called Steel Bridge. I'll talk about these later, but I feel like it was just important to mention. And then as for the classes I took in the engineering program here, I took IED, CEA, and EDD. And then here I've shared some of my work from here. This was my EDD capstone project. It was like a shoe thing where we wanted to make a so you could wear a shoe in any environment. You know, it didn't work that good, but we got it done. This was from CEA, where we had to design a backyard for, I believe it was, I don't remember his name, but
Pomona.
yes, we had to design a backyard for him, and this got, I think, like third place out of our class. This was from IED. I'm not sure, it was just like a SketchUp introduction. It was ugly, but it worked. This was another CEA project where we did a balsa wood bridge. Did a little bit of load testing and using more glue wins. So first off, I'm going to start off with what is civil engineering. So it's really just a branch of engineering that focuses on the design of both natural and man-made environments. So this can be things like your buildings, your bridges, your roads, your water infrastructure, and also things that you may not notice, like the ground you stand on, like landfills, and just making sure everything's in place. Like the world around you, if it exists, it's probably the result of some civil engineering. But what I'm really interested in is structural engineering. So first off, what really makes this different? Because in reality, it's like a subsection of civil engineering. It's a very focused division within it. Because civil engineering is very broad. There's all the topics that I mentioned earlier, but you know they might not catch your interest. So me personally, things like geotechnical, things like water, things like roads, they don't get me moving in the day. Like, if I see that on my schedule, I'm not exactly thrilled. You know, I got to get it done, but I'm not jumping for joy about water. But that's what really, especially about structural, because it allows me to keep focused on what my interests are. So this is mainly the focus of structural design and analysis of both buildings and bridges. Those are your two most common things. It's mainly saying like, what size beam do I need to use? What material should I use? How do I bring this into reality? And then it's really just making sure everything will work. Everything can be brought into life. So why did I choose structural? Because one thing in particular is that I'm very interested in problem solving. People say that a degree in engineering is a degree in critical thinking. Because what you do is you're constantly solving problems. Whether or not you really see it that way is, it's a mindset, because you are given problems, you solve them, there's multiple ways to tackle them, but that is what you do. Each industry has their own deal, but at its core, it's the same. And then additionally, with structural, there is a certain real life impact that not every major has, because your building that you design will be brought into real life. This is something you will see. There will be real world, hopefully not consequences, hopefully all positives, but there will be an impact that you have, and it is tangible. And then additionally, that you do have to be pushing boundaries to make the architect's dreams happen. You know, my architects, they'll do your outside work, but what your job really is that you have to figure out, can I make this happen? Because you can have all of the design you want, but if it's not actually possible, you're not really getting anywhere. And then part of my job actually is I argue with architects all day about, is this the right way to do it? Does this meet their standards? Is this even possible? Usually they're wrong, because I'm always right, they're not. But that's what happens. So now, I don't want to get too deep into coursework, because I could go on all about shear moment diagrams, but I mean, you guys probably don't want to hear about that. Probably don't know what I'm talking about, and it wouldn't be fun. So I'll get into more of my personal experiences that I've had at Cal Poly. So this is the first one that I mentioned with. It's called PCI, the Pre-Stressed Concrete Institute. So this is a competition that I did last year. It was more of an introduction into the whole club competition scene that I'm involved in now, but I do think it was a good experience, and although we didn't do great, we got 6 out of 14 or something, I do think it's worth sharing, because it's really a competition to see who can make our strongest pre-stressed concrete beam. You are given a certain set of parameters, you're given materials, time, and you just have to create. You have a design going in, and you have a result coming out. Hopefully they match, hopefully they work. In our case, ours didn't. But it is the experience along the way that I do think made the difference, because we did multiple trials, and these trials, they didn't all come into a good place, but what we do is we learned from these trials and just kept building into hopefully something that did work. So I have a couple pictures from this event. On the far left, that's when we snapped our beam in half using this specific machine. It held 1,000 pounds. Not great, but it did something. And then just more pictures from the actual competition itself. This is when our first trial where we casted our beam. We made the mistake of putting it all on one side. The issue was that, we couldn't actually take out our beam, so we had to physically break open our wooden barrier, which it didn't work. But on our next rendition, we figured it out. We worked through our issue, worked in our middle. We got our silly guitar strings in properly, maybe cut a couple hands, but it was all part of the process. And that generally just made some friends along the way, and I do think was a good thing. I thought it was cool with our 2 drills, but... And then this brings us into my second experience in college that I'm currently involved with right now. It's called the Steel Bridge Team. So what this competition involves in, we have to design, fabricate, and actually construct a bridge that fits a certain set of parameters. So this bridge is 20 feet long, it's broken into 3-foot sections, and we're really trying to see how cheap we can make this bridge and just how strong we can make it. So last year's competition is, it hold 2,500 pounds of load, and the #1 school, which is University of Florida, they won 5 years in a row. Theirs was 150 pounds, and it only bent down 0.2 inches on each side. So that's, can you imagine, 0.2 inches, that's nothing. And we'd make this happen. So this was our bridge from last year. It was the only bridge in the whole country at the national competition that decided to do a top arch, because sometimes, one thing at Cal is we really wanted to see what we can do. How much can we push our boundaries? Can we make something different happen? And it was just part of an innovative experience that they all wanted to get with. Now, we didn't do great because a top arch it's harder to do. There's no point in doing it. It just looks cool. Ours didn't even look that cool. But we got 20th place out of 250 schools nationwide. I feel like they did pretty good. This year we're gonna do better because I'm leading the design. Well, I don't make mistakes, surely. But what I really want to get into is that when you're designing something, specifically like a structure, there is going to be a process. There's going to be mistakes. There's going to be places where you say, damn, I messed up. But it's all about how you work through it. So this was my first design I've been working on throughout the summer. You know, it doesn't look bad from here in AutoCAD. I thought it was fine. But when I actually tested everything and brought it into the software, it's called SAP 2000. It's ugly. You're never going to use it here. You probably won't use it in college either because it's ugly. I actually tested my bridge, and as you can see, there's a very crucial mistake here. I don't know if would anyone like to point out my mistake in here? It's very surface level. It's not flat. If you have a bridge, you can't go across it, it's not flat.
No.
Imagine you tried to drive across this, you're not gonna make it. But what that did teach me is that I messed up somewhere. And this somewhere was everywhere, which led me to make a new design, which can be seen here. Now this is a pretty refined down version of it. I've gone through four stages-ish. I've gone through all my optimizations, and this is my final stress diagram. So I think it's all right. We're in a good place. We're working through it. And this project will go until May of next year, where I'll just keep going at this. Eventually, this will be brought into real life. But another thing that I do think is important is that this club just has taught me more things than I'd ever use, because nobody uses this software in class. But now that I've gained this experience, I do think it's elevated me to a place that I would not have been before. And I'll kind of touch on this like in a later slide about like what I've learned throughout college, but I do think that's just worth pointing out right now so we know where this came from. And now, as I felt it'd be important to do like general school tips because I'm in my senior year of college. I've been through it more. There is a good chance if there's an issue that you've had, I've had it too, but I've had more time to work through these and figure out kind of what works, at least for myself. So one of the first things is, these are kind of general, but use the resources available. You know, these people here, they want you to succeed. They're here to help you succeed. If you got questions, you can ask them. And just generally, like that was mentioned earlier, you guys have access to softwares that most people do not. Like, if you really want to get ahead, you can use these resources. You can become so far advanced over everyone else that you're competing with. Well, not really competing, but at some point competing with. Because just knowing these fundamental processes gives you such like an advantage once you're in college. Like, I've just working with AutoCAD. We've done lots of CAD software throughout this program, and once I got into college, it all translated easy. You know, I didn't need the intro class about how to draw a line. I've met juniors that couldn't draw a line, but here, you know, we've done it all before, and that just knowing this is something that you can fall back on. You already have this experience. You've been through it. You've done the hard work at the beginning, and that you should utilize it while you can. Because a lot of these softwares here are very good. A lot of these resources are very good. You are in a great position to succeed as long as you want it. And then that goes to the next tip of that. Go to all the events you can. You know, some of these events seem a little silly. Like, I went to a club fair yesterday just to sit in front of our booth. You know, do I think it was a great time? Not really. Would I do it again? No, but I learned that. I learned I wouldn't do it again. I met the people that I wouldn't have met before. And that even if you think these events are silly, like a Chipotle fundraiser here. I know you guys probably do those. You know, I don't even like Chipotle, but even if I did, I would still go to it because you meet these people. Worst case scenario, you don't like it, and you could just not do it again. But how would you know that if you don't do it? And then additionally, there's not always a correct way to go about something. You know, there is a process. Everyone has their own process. Each problem is not always a unique solution, but there's different ways to get there. Like me personally, I like to, I'm kind of like a brute force method. Like, if I have a problem, I'll just keep going at it. It's not always good. It doesn't usually work. You know, sometimes it does. But using this, there's multiple ways to attack it. Like, if I really was smart about it, I could try to do something else. I could shift my focus. I could ask for help. But that just kind of goes to say that there's not always a correct way to do it. Everyone has their ways of working. Some work better for certain cases, some work better for others, but it's not uniform. And now I'm just gonna go into a little bit about things that I wish I knew before I was this deep into my career. Well, not a career, I have like an internship, but no real job. And then is that making connections with people really makes a difference. I know everyone says it, talk to people, make the network, that's the word. But it does make that difference because these people that I've met, say in like my orientation, I didn't think I'd really get to know them or anything, but I've taken class with them for 4 years and people really bring out the best in everyone because when you meet more people, that just means there's more perspectives on everything, and more perspectives means what? More ideas are flowing. If more ideas are flowing, you're gonna see things that you wouldn't have seen before because, I mean, as an individual, when do you really think you're wrong? Never. And if you never think you're wrong, you're just gonna keep going at it like tunnel vision because you can't see the bigger picture always. And getting to know these people, getting to understand their points of view really does go a long way. And additionally, like at the point where I'm at, having this network is so nice because say like I am looking for a job. Let's put up a hypothetical here. I can know people at all these companies now that I wouldn't have known before. If I was just like isolationist, go to class, go in, go out, these experiences wouldn't be there. That's actually how I landed my internship as a whole because I know a guy who said, bro, I think you do a good fit, bro. Wasn't, but it was getting in. It was learning something. It was figuring all that out. And the next thing is that getting involved with clubs will give you like practical knowledge that elevates you beyond what is said in the classroom. Specifically for engineering, you're working with books, you're working with numbers. I could draw all the beams I want on paper, but how do I know what these beams really are? And that's something that like being in Steel Bridge has really shown me because I could say hypothetically I have this 2 foot long piece that's 6 inches thick. But is that even feasible in real life? And sometimes it's not because I just haven't seen that or I don't know what real life involves. And that it just elevates you at a stage where it kind of works with your learning. And that generally another thing is that there's less pressure than you think because I don't know if you've seen, I always see the TikToks on my feed because that's all I get. When it's like, oh dude, I'm pulling all-nighters every week, this degree's impossible, I'm cooked, bro. You see the University of Waterloo, the dude's like balding after it. But no, it's not that bad. Like if you really want to get after it, you'll like what you do. You like what you do, what they say, you like what you do, it doesn't work. You're still doing work, but at least it's enjoyable work. And that's generally like, even if you are struggling, support systems are in place. Like, I know I didn't do good in a couple classes, but if I really wanted to get after it again, I could retake that class and there's like great forgiveness. I know people who failed classes and they come back, they get at it stronger. I've made my bridges that are wrong, but there's always a guy that's there to help me with it. At least at Cal Poly Pomona, we have like a great support staff. We have a pretty big department. There's always people that if you really want to learn from them, they are there for you. And that it just generally makes your life easier. Like, I don't know how to use this stupid software, but we have a great guy. His name is Dr. Lomiento. He's very great. He shows me everything. And that you should always really be trying to balance your lifestyle. So my first 2 years at Cal Poly, I was just straight taking a ton of units, not really liking it, and then I was just working too. I didn't have time for any like social life or any activities outside of school. I think that was probably my worst mistake I've made while in my time at Cal Poly because I didn't grow as a person. I can know all the stupid facts, all the numbers that I know, but what did I really gain out of it? I didn't learn anything about the people. I didn't test this knowledge into real life. And that now that I've kind of laid back on the classes because I don't need as many units, I've cut down on work a little bit. And that generally, I feel like I've grown more as a person in these last 2 years than I did, say, in my last 6 before it. Because now I'm really seeing what I should be getting out of it instead of just getting things out of it. I'm not staying up all day doing homework. I mean, sometimes, but less. And then something that I actually wanted to get on about that I didn't mention here is that to be an engineer, everyone thinks you need to be crazy with numbers. You know, you got to be some human calculator. But in reality, that's not the case. Most of the math I deal with, even in these 4,000 level classes, which are like senior bordering master's classes, I'm just using algebra. I'm using like, sometimes they use trig, and I'll be like, oh my god, you guys are killing me. I don't know if anyone here is involved, have gone into like the AP calculuses yet, but if you know what an integral is, I've done maybe like 1 or 2 in the last couple of years. It's just, you really need to be good with numbers to derive formulas, but there's a reason the formula's already derived. You're not doing it. I'm not gonna create some theoretical equation when one already exists. But engineering, it's seen as numbers, but in reality, there's also like an art aspect to it because you're trying to figure out things. You're trying to design. You know, your design involves a lot more math than say like an art, but at its core, it is the same deal. And that, I just wanted to end it off with like a picture of showing these are a lot of the people I've met throughout my time at Cal Poly. These are like my peers. These are my competition team members. This is like half our department. Well, not half. It's a big part of the department that I'm involved with. And that, you see, people are smiling. We got all of our awards. And that this is just connections that I feel like going through this program has really helped me attain. I've grown a lot from them. They've grown a little bit because of me, I hope. Hopefully we've won a little bit because of me. Not really. This year it'll change. And yeah, that's all I really got. If you got any questions, now would be a great time to ask, or really any time to ask. Pretty available. But that's all I got.
I'm gonna pause.
You described design as a process that involves making mistakes, trial and error. Can you describe one specific instance where you experienced making a mistake and then learning from it?
One experience where I had a big mistake, I could go like, just back to my bridge thing that I kind of mentioned on earlier. You see, I had this great master plan for this design, but when I actually tested in real life, well, not real life, in the software, everything just didn't work. Like my bridge was looking like a rainbow almost. It's supposed to be flat. It's not flat. My members are all clipping through each other. This thing is just falling apart. But what I kind of did was, first thing, I didn't really know what my issue was. I knew there was an issue, but I felt the best thing to do was, just ask my advisor. He's there, he's smart, and these people are here to help. So he's kind of said, oh, have you looked at this? And I say, I didn't even know that's real. So, but knowing him pointing that out to me, I just kind of figured out, it just kind of started off like a chain reaction almost. Like, first issue, solved, but that led to a second issue, solved, and eventually you kind of just keep going down this path where it's like, you'll get to something at some point. And hopefully that something works. My something didn't. That's why I'm on my third bridge instead of the second. The second sucked too. But, and then just like another thing where in class, like in Calc 3, I was struggling bad. Like I was getting like D's on the test, and then just figured out, I just started asking people like, hey, can you help me out with this? Can you show me what I'm doing wrong? And then eventually just kind of I like lived in the library freshman year. And then eventually did more problems, just kept doing these, kept asking more people for their perspectives. Some people had some crazy methods I would have never thought of. And just keep doing this repetition. Eventually I pass with a C.
I don't know if I missed it, but what do you hope to do in the future after you graduate? What are your future plans?
So currently, I'm hoping I will be applying to like a master's program. Most of the applications open up next month, so that's what I'm going to be mainly busy with. So I also hope to be doing like, I hope I can get a job. Like I like money. They pay me. They pay good. So that's the current plan. Current plan is to get a master's degree, and then hopefully enter at like a good structural engineering firm, maybe make a little difference on the world, hopefully. So that's all I really got. I'm kind of close. I haven't really thought too deep about everything because there's so much like up in the air. Like whether or not about where I'm gonna go, I don't know that. Because obviously I haven't gotten accepted. Yeah, I don't know where I'm gonna work at because that's kind of dependent on what schools I get into. But it's really, to say I have a hard set, like, this is what I'm gonna do, this is where I'm gonna do it. No, but general idea, hopefully be employed. That's main goal, number one. We'll go from there.
So you see maybe structural engineering, work in a construction management firm or design engineering firm?
Gotta get something in the door.
Yeah.
Inspired you to study engineering?
So the big thing that inspired me to study engineering was, one, I like math. I'm not good at writing. I'm very good at math though, and that kind of works inside it. And then the biggest thing that for me is that engineering, it's constantly doing puzzles, constantly problem solving, because you're given these real life. Instead of a puzzle though, you get this idea from an architect. You have to fit within these parameters. You have to work with this code. The code book's like that thick. It's giant. And working with all of these obstacles makes you think in a very creative way that you need to make this happen, and how are you going to make this happen? Knowing this, it kind of feels like a competitive drive almost to me, because I want to make these things happen. I want to see results. I want to solve problems. And that this is just a very good catalyst for me to do it. And that I do think it's a very good match for me also, because I do like the math. I do like the numbers. I mean, I still have to write, but it's less, and I can kind of sidestep most of it.
Have they gone to West Point Bridge yet?
Huh?
My name is Ting, part of the No Bridges committee, and this is the venture into architect major. Now, raise of hands, who's into the architect major? Who's willing to enter it? Alright, a few people. Alright, quick question. What did the project always start with? What do all architect projects start with?
Sketch.
Yeah, that's right, sketches. There you go. All the rough sketches that you've done, these are the ones I have in a certain IED, and in ACE that you'll see like certain projects that we'll get to later on. But certainly every architect starts from somewhere. Every architect major starts from somewhere. It all comes from the sketches. Just try to put the rough ideas in, what kind of building that you want to capture using different constraints, or whatever idea that you have or that can solve a certain goal or solution. Alright, and next up we have like building traces that you'll go over into this CEA class. We'll get into, you'll get into how the buildings are made, what kind of designs that are placed into like different sections of areas. So in cubicle houses, you have more like 90-degree ruler-based drawings. Sometimes you'll have sketches that have more hatches during the roofs, and maybe even like interior views that are more symmetrical and such. These are important sketches that to keep in mind when making your portfolio. Raise a hand, who has done on-chip in IED class? I should see every single hand pop up. We have done on-chip. This is one of the 3 modeling softwares you start with. More coincide with engineering stuff, but the simple things you need to get into control are the commands, the dimensions, and the assembly of such. Right? In 3D modeling softwares, these 3 are very important into putting things together. Going more into it, keep in mind this is just stuff in the back of your mind that you've done within Onshape. You have used measuring tools before. You guys have used diagonal calipers before, right? When doing some of your projects, right? You have referenced the objects that you have deconstructed. You have maybe even sectional drawings, just drawings of whatever interior views that you can get within the models. In representing your ideas, you're creating these models that have that you think would be represented well. You're diagramming the assemblies, placing 3D objects into like a 2D sort of drawings to showcase what you envision. You're representing these parts by dimensioning the parts themselves, giving them a sort of scale that people can use. This is important when going into the 3D modeling software that I'll introduce. So, later on in CEA, you'll be learning SketchUp. SketchUp, you'll take, instead of going into micro details of the objects themselves, you'll be going to macro scales with these. Same things with dimensions, the same commands that you have, extrude, maybe even sweep, going to revolve or lock or whatnot. You'll have the same sort of ideas in SketchUp and just putting them into more architectural details. Lastly, we have Rhino. Rhino is going to be another program that you'll get into later on. This one's more so like the architect's world. Whoever's going to major in architect, this is the software to get into. This is what colleges will use, and maybe even your work. You will get into Rhino very soon. The same commands that you'll get. You got loft, you got sweep, you got extrude. Same things that go into Rhino, it's just a different scale, once again. And using Rhino, you can get into certain projects like this one. This one is my solid professor design project in 2022. And using the certain constraints and goals and ideas, I sketched out certain ideas. I gave it the dimensions that I want it to be, and I put in everything into the Rhino software to construct whatever I envisioned. And in the end, you can finalize these renders to showcase this project off to the world. What is this project? I have no clue. It's a bridge. Can the bridge hold up? Ask him. It probably doesn't. It's too heavy. It's a stainless steel bridge. It's a dumb idea for now, but it's an idea, and whatever idea I had envisioned in my head, I placed it into the 3D model software, and I constructed it to whatever constraints and goals I had in mind. Next up, we have some physical modeling. So take into account like whatever tools that you had in Rhino, and split in half, put it into whatever physical modelings that you have. In the architect major, you're going to want a lot of physical models. In CA or IED, take pictures of whatever models that you make. These are important for portfolios and demonstrating ideas that maybe cannot be placed in 3D modeling softwares, right? The type of materials that you use, important, right? Maybe chipped off cardboard, like trash cardboard that you find, but has these little ridges in them. You can place them into architectural models. Some recycled like sticks that you found in the street, take it, put it into the architecture model, and showcases like recycled materials. Or the idea itself. This is Chinese architecture, right? Just constructing the model and give your basis on what you found. These are important in portfolios when you go into the architect major. Now, in ACE, one of my projects is Etowanda High School automobile class. Our goal was to retrofit the entire, retrofit the classroom to fit the program more smoothly. And so given goals and specifications, certain overviews of the projects are given, and now actual like constraints and documents are given to input like actual architectural details into it. We're able to construct some, we're able to design a project and construct whatever is needed within the program, right? ACE provides a lot of different opportunities that you'll never get in 100 years in either CA or any other school. In one of the programs that we've done, we went to site visit. During those site visits, we're looking for dimensioning, positioning of tables and whatnot. What kind of program is it, right? The design of the actual room itself. How comfortable is the room itself right now? How can we change that comfortability? And what is the function of that program? How do we take that function and improve it, or even retrofit it to fit the certain needs that the automobile shop needs today? So ACE gave us the opportunity to take those site visits and input our own understanding of the program into architecture major. Yeah, and in the end, you present these project presentations, finalize these 3D models that you have, the ideas that you have, and in the end, you can even make them into physical models to showcase different ideas that you had way back prior, and the movability of such things is much more easier than 3D modeling itself. Lastly, we go into like Mars habitat project. This one's just like constraint is within Mars. How do you construct something that's within Mars, right? And in the end, we just presented a project with like a ton of photos and just kind of ideas that bounced off each other to construct something that we thought was pretty cool and works for whatever Mars habitat project that we wanted. And so the model photos you see back there can also be shown all the way in the back of the room. Yeah. And that was the project that we constructed for this project. Lastly, I want to just go over some portfolio projects I've done, just to inspire or maybe even get you into the right track when submitting your portfolio for to become an architect major. In these certain projects, I just had simple ideas like origami, making stuff with sugar. Why? I don't know. The the different forms of sugar allowed me to construct different things that I wanted to do. Why origami? I liked origami. Origami gave me different forms that I can use to make whatever buildings I want. Buildings or even like smaller objects, just to study and understand them. What the professors in those in the architecture major want is just what makes this project you. What is your passion, and how do you take that passion to construct something that will be more beneficial to the world? Yeah. Next up, we get into college presentations. And before I do so, I just want to make a disclaimer. The architect major is very hard. It is very hard. The work you see up here, less than half of my first year work is up there. It is a lot of work. It is a 5-year commitment, and you're gonna meet professors that you, at the bottom of your gut, you would hate, but still have to charge through. You'll meet collaborators or friends, or people that you work with, to be very annoying. You're gonna have to work a ton around the clock, a lot of projects, a lot of time into these projects. But at the end of the day, these projects that I presented up here, I had fun. This is my passion. I want to push this out to the world. This is the type of creativity that I have. This is mine. All right. First off, what do all architecture projects start with?
Sketching.
Yeah, all the different sketches. So back in college, they don't care about the fundamentals you have. They're gonna push it back into your head. So starting with the fundamentals of line thickness, grid hatchings, all these different things just to shade in different cubes. How do you make the cubes into different sections? What do you do with these cubes? How do you now then project the cubes into different ways? In these 3D modeling softwares, you notice that sometimes you can change an object from isometric to 2D. Then you can change an object from 2D to isometric, from top, side, and other views, right? Auxiliary views. Then you project those views to view the cube in certain ways using your hand and projecting lines. Projecting them in various sections, so cutting the cube with your mind and placing them onto a piece of paper. Now you're projecting to rotate the object in different ways using the top and auxiliary view. And lastly, you can project them using shadows. Project shadows using the cube's top and side views, right? All these basic stuff that you learn, these are like engineering tips that you can get. And then you put in your architectural mind, your craziness, your creativity into these projects. And then you can get something like this, the composition that you put in, all the different drawings that you've done before, you can put them together to formulate something that you want to create. So in this certain case, I have a cube that wants to rotate certain ways in the top view. Then I want to have rotated different ways in the bottom view. And suddenly, now we can combine the two using the two top views, which are the same. And if they add up, that means the cubes in all these different drawings are equal. Right? All the different compositions you can put in. This is just all the basics, just putting together to whatever I want to formulate. These are the types of projects that you'll be getting into in the architect major. These are the types of projects that maybe you want to push forward. Go even crazier than this. Go even way beyond what you think, right? Whatever drawings that I had on a piece of paper, now I can put them in Rhino. I can put them on whatever software I want. I can place this into Adobe Illustrator and give it whatever colors I want. This is the composition I made using just cubes. This is just cubes. Cubes, lines, and whatever shadows I made. Just cubes. And you can make compositions as crazy as this. Other projects I have, you can make designs based off just arbitrary rules that you put in. This is just there's something called rule-based drawings, which are drawings just made off different constraints and rules that you put in for yourself. Using those drawings, you can then put them into plug them into 3D models, and after putting 3D models, you can construct them into different various forms and ideas that you have. What is the functionality of this thing? For maybe light, displaying apertures and lights, or maybe even like just structural like platforms and whatnot. Is it feasible? Ask him. I don't know. It's probably not. The stuff is floating, but this is an idea that I had. I wanted to put in there, and it was based off of the rules and constraints that maybe the outside world has, or whatever I put it, whatever rule I had or goal in mind. And in the end, you have something called a pinup. Those are presentations placed all over the board. This is work I've done over the course of a year, and these are just ideas that you shove into like a tiny piece of board so that your professor can grade you for 5 minutes, maybe. It's a lot of work. It is a lot of effort to put into. A lot of time and effort placed into these certain projects, but these are your passions. You want to make them come into life. You're going to go through processes that behind this pinup board you've never saw. You never knew what went into, your professor will never know what went behind all these little different details and all these different strokes of your pen. But in the end of the day, you want to convey your idea, you want to represent it as your own project. This is what makes you, you, and this is your gift to the architecture book. Now, just something to inspire you. This is something I've made using Grasshopper, which is a program within Rhino. And this is just the type of program that I've tried just out of my sheer curiosity, just try and make something out of it. So using the control panels to give various constraints, the command chain to activate whatever I want, whatever commands you've done, and the final renders to give everything just a finishing touch. You can construct whatever you want. This Grasshopper is a parametric tool, and basically what that means is the commands that you saw in Onshape, in SketchUp, in Rhino, it now repeats them every second or so and continues on whatever measurements or constraints you give it. So with whatever stupid tools, you can create whatever stupid things you want, but these are things that maybe inspire you. Maybe it's not Grasshopper that inspires you. Maybe it's a different program in Blender, the nodes in Blender, whatever software that you have access to in the computers here in this room. You can do whatever you want. And that's something special. Using whatever that I created, make a movie out of it, make a poster out of it. Well, you can make a rendering out of it. Pretty cool wallpaper. So all the different things, all the different tools that you find in the computers, you can utilize. All the tools that Mr. Collins has in the back, utilize them. 3D printers are expensive. You break it, maybe you don't have to pay for it, I don't know.
Don't say that.
All the woodworking stuff, I've met people in my sophomore year, never touch woodworking stuff. You're required to in your first year. If you can have access to all the wood component stuff, you have access to almost more stuff in my college. It's crazy. You have the whole world out there. You have the whole world in here to start working. And just going forward, these are just different projects I've done using Grasshopper, right? Just how to change the facade's design to encompass light and air, what kind of design I can make using the facade, what kind of buildings I can draw using those different constraints that I gave. More so the different types of models that you will be making in the architecture major. This is just going to first and second year. And higher levels, they get crazier high skyscraper buildings as well. So in the end, you get stupid drawings like this. I don't know, you can find something useful out of them. And you can construct whatever your mind can think of. Right, given the models or whatever you were given, it's the Collins. And yeah, thank you. Is there any questions?
You talked about a lot how architecture is, if you reduce it to sort of its most fundamental nature, it's very artistic in the way that you design and stuff, and engineering is contrasted to that as being more mathematical, more based in reality and feasibility, what can and can't hold up. So how do architects and engineers sort of reconcile those differences between their fields?
Functionality. All comes down to functionality. Whatever you design has to function as something. Whatever you do has to represent or make something happen, right? The building is for you to occupy. Is it small because you want it to be less structurally dense, or do you want it to be tall so that it can encompass more of a square footage, right? These are things that the architect and the engineer have to agree on. Otherwise, whatever design that I make, whatever design he wants, will never come true. Those are the stuff that functionality comes first. Always, I'd say. Because freehand sketching, we have like stuff, rough sketches that I had way back in the beginning, like these. These took like 5-10 minutes or whatnot, right? Very easy to do, but they came from the mind. Everything that I thought of, there was maybe like a 30-minute gap where I had to think about what to sketch. There were eraser marks everywhere. Maybe it took an hour to sketch those things out. And they're like small and stuff, right? So most people think, oh, 5-minute sketch, easy, right? But maybe the difference between like the sketches that I made here and maybe the traces I made here are just what comes into mind when making these. During the tracing.
Ting, I got a question.
Yes.
So we have several people here who've been thinking about architecture as a potential future career pathway. What advice would you give them while they're in high school? What should they be thinking about? What should they be considering? And then what would you tell them that you didn't know when you were in high school that you would want them to know?
I guess philosophical answer would be find your identity within this craziness. What is your ideas? What kind of fonts? Like it comes down to like whatever you envision is kind of yours things. So every time I've been switching slides, the fonts have been changing, right? I'm trying to find the identity of sorts. Maybe the design of such is changing. Which one? All these projects all represent me in different ways, right? All these different projects. What makes this project yours, right? What is your passion within this? Because architecture major is very hard. You're gonna burn out very quickly if you don't find what you're looking for. And just go all out. Just go find whatever you wish, you envision that you think it's creative or not. Sometimes it doesn't even need to be an architect, a building or a bridge or whatnot. It can be as simple as just like whatever, maybe like a cosplay staffel that you're making, or maybe even like certain origami shapes that you're folding in. Like how do you make these certain things and turn this project into yours? You're not gonna be used to like certain traditions, certain places, and like how many of you guys drive? Yeah, in most cases, you're gonna lose that privilege when you don't do it. Traditions that you'd normally never find here in the West Coast. So in physical, like temperature changes. The city's a lot larger than the suburbans here, or even like downtown LA. Like New York's a lot larger, a lot more crowded than what you'd imagine around West Coast.
Minutes away. If I drive and there's crazy traffic from my house, it takes me maybe 20. So that's the thing. That's one thing that's really nice because I just live at home. I don't have to pay for housing. I rarely have to cook my own food. It's just I'm not really self-supporting myself. It's easy. It just allows me to focus on what I really want. And as for the payment, everyone says you're gonna be in crazy college debt. It's gonna be super expensive. My tuition's like $7K a year. 4 years, $28K. I mean, that's easy. I don't want to be that guy, but I work throughout my school and I've been able to pay it with no issue at all. I don't have to worry about the money. I don't have to worry about the house. I don't have to worry about cooking for myself. I just drive to school. That's about it. I know some people say, oh, but you're gonna miss the traditional college experience because you're not living on the campus. You're not always gonna be there for the events. But in reality, there's no real college experience. It's what you make out of it. Because I've still met friends. You're not gonna be some loner. You just drive in, drive out. That's it. You're gonna meet people. I know these people. I hang out with these people. Is it like the same as high school where you're gonna know everyone? Probably not. But it's not as bad as people make it seem because you're gonna meet people. Sure, you might not be in a frat. But at least at Cal Poly, that's not even like a big thing at Cal Poly anyways. There's when we have fun at Cal Poly, we go to the library. Our ideas home, we maybe hit the Panda Express before if we're feeling crazy. That's
Now you give the other side of the spectrum.
I can take this in one of two ways. If you go into the architect major into Cal Poly, Pomona, you get kind of the same thing, same treatment. My friends over there tell me the tuition is just a little bit more expensive than 7K. I want to say like 8 to 9K for all the classes you're going to take because studio classes are highly valuable and still very expensive. But you do need to take those for credentials for architecture. The other way you can take it is how is it being an architect in all the way in the East Coast? When you move, I want to say very expensive. This is an opportunity, this is my once in a lifetime opportunity to get into. But I know for a fact a lot of people aren't able to afford the 20K, the 20K tuition for every year, and that's with a 100K scholarship on top of it for all throughout those 5 years. So even with that scholarship, it's still very expensive to take that opportunity to go into the East Coast. But I will say the experience that you gain over there is very valuable. Something that hope if you do move into the East Coast, you take your time to just chill out, find everything that you find stuff that maybe in the West Coast you'd never be able to experience. Maybe it's a city life, maybe it's the street food, maybe it's whatever museums that you never get to experience in the West Coast. This is, again, it's a very expensive tuition, but I would say for me, even with scholarship, yeah, it's worth it for